section has to do with permutations. Permutations is a group of objects or people that's arranged in a certain order. So it's the number of different possibilities when you have a group of objects or people arranged in a certain order. So if I have 20 questions for a test and I'm creating tests, the order of those questions makes a difference if I want different versions. So that order would be a permutation. Now if I'm just choosing 3 questions, the order doesn't matter. That would be something called a combination, and we'll look at that. But if I wanted to say we had a contest and I wanted to know how many different possibilities or combination, or how many different possibilities for first place, second place, third place, and I'm choosing the first one, the first person that I choose is first place. That order makes a difference. Books on a shelf, the order makes a difference. So those are all examples of permutations. So we're going to look at this first question here. It says, how many 5-number license plates can be made using the digits 0, 1, 2, 3, 4, and 5? And repetitions are allowed. So that means I can have repeater numbers. Now, we're going to make the assumption that 0 could, it doesn't specify, we're going to make the assumption for this one, since it's license plates, you could have a 0 be the beginning number. So I have 1, 2, 3, 4, 5, 6 possible numbers. So if repetitions are allowed, then I have my first digit, so my first number, second number, third number, fourth number, fifth number. Now, if repetitions are allowed, I have 6 possibilities for the first one. I have 6 possibilities for the second, 6 possibilities for the third, 6 possibilities for the fourth, 6 possibilities for the fifth number. Because they could all be 0, 1, 2, and they could all be the same number. Now, if they are not allowed, this is another example of this permutation. If they're not allowed, there is a formula that you can use, but sometimes the formula, like in this case, the formula wouldn't have worked because repetitions are allowed. It would work in this case. So again, we have 5 numbers. We have 6 choices for the first number. Then it's not allowed to repeat, so I've already used one of those numbers. So then I have 5, I have 4, I have 3, and I have 2. And I would multiply those all together to give me the number of ways. When you do your assignment, I need to see what you're multiplying or if you're using the formula. So now let's look at number 2. A teacher wants to write an ordered, key there, 4-question test from a pool of 12 questions. How many different forms of the test can the teacher write? So I have 4 questions. I have 12 possibilities for the first one. I'm not going to put the same question on there twice, so repetition is not allowed. I have 11 for the second, I have 10, and then I have 9. And I would multiply those all together, and that would give me the number of tests, or the number of ways that I could do that. Now there is a formula, and the formula says the number of permutations of n distinct objects. So n distinct objects means distinct, let's try that again, n distinct objects, meaning they're unique or they are completely separate. So n distinct objects taken r at a time is given by this. We would say n distinct objects taken r at a time is n factorial over n minus r factorial. So in our example, I had 12 questions. So that would be my 12 distinct objects. So that's my n. And I'm taking 4 at a time. So that would be my r. So I would have 12 factorial divided by 12 minus 4 factorial, which is the same as saying 12 factorial divided by 8 factorial, which is the same thing as 12, 11, 10, 9, 8, 7, 6, and so on, divided by 8, 7, 6, and so on. Those are all going to cancel and leave you with the thing that I did right here. So there's another way to do it. The repetitions that are allowed you need to do differently. However, you could use this formula to do it as well. It also can be used if you have a graphing calculator, and you go to, so we had 12, and then we go to math, we go over to probability, down to NPR, and then it was 12, and we're taking 4 objects. That gives us 11,888. I'm sorry, 11,880. Or I could do 12 times 11 times 10 times 9, and I get the same answer. So that was, I put in the 12 first, then I hit the math, I went over to PRB, down to NPR. But you can very easily, I don't usually use this, I usually just do it by hand. Now we also have another case, and that is finding the number of permutations of letters of words when we have words that repeat, or we have letters that repeat. So I'm going to do an example with Mississippi. Mississippi is M-I-S-S-I-S-S-I-P-P-I. So it says, how many different ways can these letters be rearranged? Well, these 4 I's, they're not unique. So me switching those 2 I's, it doesn't really make a difference. So we have to add an extra layer to this. We need to figure out the number of combinations, but then we need to divide it by those repeats. So this is how we're going to do it. We have 11 letters. Okay, so that is our N. And we are taking basically, so we need to divide that. So we have 11 factorial, because there is 11 ways to have the first letter, 10 ways to do the second. 9, 8, because we have 11 and we're choosing 11, so it's just 11 factorial. However, we have these repeats, so we need to divide by those repeats. There happens to be 4 I's, so we have combinations where those 4 I's are just flipping order, but it's the same word. So we're going to divide that by 4 factorial, and those are for my I's. I have 1, 2, 3, 4 S's. So I need to divide by another 4 factorial, because I'm just moving those S's around and it's not really changing the word. And I have 2 I's. So I need to divide by those 2 I's factorial. So when I look at this, I can kind of think about it like this. I have 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, divided by 4, 3, 2, 1, 4, 3, 2, 1, and 2, 1. I just wrote those out. So it's really a canceling thing. 3 and 2 cancel with my 6. 2 and 4 cancel with my 8. And that cancels everything out. And so then I can multiply what I have left over. You could also put that in your calculator and it should be able to do it for you. Your answer should be 34,650 possible ways to order those letters. So let's look at, on the back you had deed. How many letters do we have? We have 4 letters. And how many letters repeat? Well, I've got 2 D's, so I'll have 2 factorial. Those are my D's. And then I have 2 E's. So we have 4, 3, 2, 1, divided by 2, 1, 2, 1. And that would give me 6 different ways to do it. So hopefully that helps.